Today lesson we learn the last method of estimating, that is unit cost estimate. So for the objective today, we try to produce the quantity takeoff for the unit cost estimate, and then we compile the cost estimate using unit cost estimate method and apply the Revlon software to facilitate cost estimate. Uh, and with that, we just try to review what is this method about and what is the accuracy level we want to achieve. And this graph I show you for every lesson for the cost estimate. We cover the order of magnitude, we cover the square foot and assembly or system estimates in the previous lesson. And now go move on to the last method. We deal with the estimate, that is the unit costs. And for unit costs, as you can see, it can take weeks or even months to do the estimate. It depends on how complexity of the project is, but that's the bottom line. But when you take a lot of time, a lot of effort, then the accuracy level, it will be higher. In this case, we can expect with the $2 million project, it can achieve accuracy plus minus 5% of the true construction costs of the project. So before we continue to the slide, I just want to give a few notes for this method. So first, to do the unit cost estimate, the project need to be clearly define the scope of work, and it realized in the working drawings and specification. For example, here for this project, is the wastewater treatment plant. We need to have a clear, detailed drawings, show the dimension, each item, what is that about for this project. So that is the working drawings that ready for the construction, and that need to be available so that we can continue to do the unit cost estimate. Otherwise, if we don't have the working drawing like this, then we go back to the previous three method: order of magnitude, square foot or cubic foot cost estimate, or assembly or system estimate that we discussed in the previous lesson. And it requires the current and accurate cost data. Because to do the estimate, we only have two items. The first is the quantity, that for this method is from the drawing and specification. And the cost data, it can be from the company database that apply current. And then if for the engineer, if they don't have a database for it own, then you can get something like ISMIN, building cost data, for example, this one. And every year they publish the cost data for, in this case, building construction, that for heavy construction, also have for green building construction. All of that they have published every year. And in this book, 2015, but you have the current version in 2020. So that the second item require current and accurate cost data. For real industry, if you rely on this to bid a project, you will not get the job, because it tend to be over estimate compared to the local cost. So it have to be customized for the company based on their productivity, based on their working method to achieve to deliver the project, to make an accurate cost data for company. But for our class, we use the ISMIN building cost data to determine the unit cost for each item. And within plus minus 5% accuracy, as I already mentioned earlier, and follow master format. So let me talk about that in a minute here for this one. So go back. For the unit cost estimate, separate construction processes into a series of steps. So make it break down further. And if we estimate for each smaller item, add them up, we assume we can determine the total cost of the project. And determine the quantity of the material moved or installed for each step. Then we first is the quantity, how much I need. And then we determine the unit cost, something that the other component we have, time the quantity with the unit cost, then we can determine the cost for that item or that step. Add on a series of steps, we can be able to determine the total cost for the project. And with that, the process for estimating, as you can see here, of course, from the project initiation, scope definition is very important, because that if we don't have a clear scope, for example, working joint, then we cannot use the unit cost estimate. And then we can take up, do the quantity take up, and that the focus for today's class as well. Do quantity take up based on the drawing. For the next lesson, we will go to the real drawing and guide you how to read the drawings and how to do the quantity takeoff from that as well. And then we get the data. Like I say, for our class, we use IS mean, construction cost data, and that we determine the direct cost. What is direct cost? We will discuss that in the later lesson videos. And then we summarize and check, review, and get the pricings. And some components need technical expertise, and that the light green in here, and that we focus in today, 2 items, how to determine the quantity from the drawings and how to determine the unit cost for that items. And then of course, finally, we can determine the cost of the project. We say follow master format, and this is the master format we are talking about. Remember, in the system or assembly estimate, we use the unit format too to do the estimate, division A, B, C, D, etc. But for the unit cost estimate, we use the master format, and that the standard that or the company use when they break down with the item, so that it's easy to communicate between the company, between the entity. So everyone should be on the same page. So here, for the master format version 2004, as you can see, total we have 90 divisions, some unreserved. It means that for future expansion, it have other technology, other item that not captured in other division. So in the industry, for example, if we're talking about the division 3, everyone relate to that is the concrete. Division 5, metal. Division 4, masonry. Or if go down to here, division 31, earthwork. 32, exterior improvement, utility, transportation. Waterway, marine construction, division 35. If you want to go to electrical, then we talk about division 26. So that everyone will say division 26, that is electrical. Now we go to the pollution and waste control equipment. Everything that deal with that item, if you have that process, then it will be division 44. Okay, waste and wastewater equipment, if we design, do the water treatment plan, wastewater treatment plan, then division 46 will be applied, and go to that item to get unit cost, go to that item to describe that division to describe the item that you need to complete for water or wastewater equipment. So that, as you can see, every division have its own purpose and description. And then the unit cost data, it apply for each division. As you can see, 9 is division 9, and then the code that is from IS mean. So division 9, if you go back here, that is the finishes, and of course you see gypsum board is the finishes work, so that is division 9. And for the cost data, as you can see, for each item, and what they have here is the first column in here. Basically, is about the labor, how many people we have, and then we have a daily output. We have the unit measure, so it's very important to understand the unit measure, and then the material, labor, equipment cost, and the direct cost, and the total cost, including overhead and profit. We will do that when I walk through in problem 2 of today's lessons. And then when you have all of that, we make a summary. So you have each item, material, labor, equipment, subcontractor, total, and that is the direct costs. We will talk about what include the direct cost later on. And then you have tax, overhead, profit, contingency to make the total project costs. That is the one-page summary of everything for the project. If you remember, I showed that the Edwardsport IGCC power plant project in system estimate, the previous lesson we have. So from that one, we go back to here to do the one of important is the quantity takeoff. If we don't do correctly the quantity, everything is wrong. We cannot capture the scope of the work. So it's very important how to do the quantity takeoff efficient. Of course, you need to understand reading how to read the drawings, and that will be the next lesson. And we have to utilize a few things. For example, take advantage of the system of building symmetry so that we can do one and its symmetry. We just time how many of them, then you can get the quantity. Don't have to repeat the same process for the same item that repeat over and over. And then make sure the measure unit, the unit that you take from the drawing, and the unit price that you get from the cost data have to be the same so that it will match. And I experienced that in one senior design a few years ago. They do the south access road for our FGCU campus. You see that from the University Village to South Village, we have an access road. And one group of senior design design the project and estimate the cost below, very low number, and they came to me to ask why it's low. They're concerned, but they could not find out why is that. So that is the problem here. The unit that they measure and then the pricing unit are not the same. And consider quantity adjustment. Whatever you put in this drawing and the one you order, it may not be the same. Sometimes you need to order extra, and that is the adjustment here about. So the next few slides we will talk about that here. So the first one, as you can see, utilize the symmetry of the system. For example, this is a triangle, and we have, of course, for triangle you have both sides in triangle. Then you just determine the area for one side times 2, you get the area for both sides. So that's the first one. If you have multi-floor building like homes home, if it repeats the same, for example, triangle here for one floor, one typical floor. If you have 1, 2, 3, 4, 5 floor, then you can reuse the same number that you do in the one typical floor and time for all other 4 floors, so that you get the quantity for triangle for all 5 floors. And then the pricing unit have to be the same as measured unit that is we're talking about. For example, here for the shingles, this roof 50 times 25. Remember, we did one problem in system estimate or assembly estimate for the roofing, and we determined that is the 2,500 square feet. But for the standard for shipment in here, it measured by square, $50 per square, for example, and you have to convert that square feet that we determined that is the measured unit to square. In this case, 100 square feet equal to 1 square, so you have to divide by 100 square feet per square to get 25 square before we apply the pricing unit measured by $50 per square. So keep that in mind, otherwise we have a mistake in the estimating. And then the last one is adjustment. And in your exam 1 reference, we have the adjustment in the page number 2. So if you don't know which number we get, I suggest you just go to that exam reference when you do the exam or the quiz and get the number from there. And just for the suggestion, a typical adjustment, for example, the steel reinforcement 10%, concrete 7%, concrete block 2%. Some problem may give you, some problem don't give. Get the number here. This is typical. It depends on how efficiency a company is. If the company manages the waste very well, they can reduce the percent of waste, and that adds up for their profit. So it's very important work efficiency, and depends on the nature of the work. As you can see, it depends on the material, nature of the work, and the company practices in managing the material. So those are the key points before we move on to the next video that apply how to do the quantity takeoff for one problem, and that is problem 1.